Hi, my name is Fahad Sami, and today I'll be going over pyruvate dehydrogenase complex deficiency, or PTSD. Just a refresher on pyruvate oxidation. So, it's basically a second metabolic process in cell after glycolysis. What it basically does, it takes the acetyl group of the pyruvate from glycolysis, combines it with um, coenzyme A to form acetyl CoA. Now, just to go over pyruvate dehydrogenase complex, which is known as PDC. Now it's basically multifunctional enzyme complex of three enzymes. So there's the E1, E2, and E3. The E1 has two parts, E1A and EB. Now these three obviously go by their own names. Today I'll just be focused on E1, which is known as pyruvate dehydrogenase. So what basically happens in the process is that it catalyzes oxidative decarboxylation of pyruvate to acetyl CoA, NADH, and CO2 obviously as well. This occurs in the mitochondrial matrix, as you can see here, and the pyruvate is transported by a process called pyruvate translocase. Now, just a visual, as we can see E1 here, E2, and E3. Now, this is the entire complex. Now, what happens here, as you can see in the pyruvate, the double carbon um, metabolic substrate. It goes through E1 with the help of TPP to E2 and E3. Now, once the pyruvate enters the double C bond, the double C or the acetyl, basically it breaks off. And E2, as you can see, the coenzyme A over here, it reacts with it, and in enzyme 2 we basically get the acetyl CoA. Now for this complex to regain its back to its normal form to go function again, the FAD needs to go to FADH2, and it's like a cycle. Now for this, what needs to happen is the NAD plus needs to reduce to NADH, and this is basically how the PDC works. Now, the pyruvate dehydrogenase complex deficiency, or PDCD, is basically a metabolic disease. It's genetically inherited, where the body is unable to efficiently break down the nutrients from food, sort of as energy. And as we can see in this picture, there's a normal baby versus a baby with PDCD. Now, what basically happens in this is that in the E1 subunit, the short arm of the X chromosome in a person, um, it's basically the disease is contained in it. Now, this subunit is known as the E1 alpha subunit pyruvate dehydrogenase gene, or in short PDHA1, and this is what causes the disease in a person. Now, treatments for this are there are a few some medications are thiamine, carnitine, lipoic acid, oral citrate. Then obviously a change in lifestyle, which is the big one, is a ketogenic diet, and then obviously genetic counseling as well. Now, basically, just to go over some of the key ones, oral citrate, what that basically does, it takes care of acidosis. Now, what that basically is that the acid levels are rise because of lactic acid buildup in the muscles. This happens because the glycogen is not broken down in the muscles once the carbs are taken in. That's why that lactic acid builds up. Now, with oral citrate, these levels are brought down and the symptoms are less prominent. Ketogenic diet, same thing. What this happens here is the low carb, high fat. The high fat gives instant energy right away to the body, and that basically helps. Now, genetic counseling is more. It's not a treatment, obviously not a cure. It's more for like the family. Now, what this happens in genetic counseling, obviously with disclosure and everything, you're given how to adapt to this kind of lifestyle, this kind of change with a person who does have PDCD. Current research that's going on this disease, the major one is in the Natural History and Advanced Genetic Study of PTCD. Now this has been going over a span of years on around 200 subjects. Obviously, because this disease is extremely rare, there's not many subjects that can be tested on. Therefore, it's taking a longer period of time. There are other foundations that are supporting this research, however, not fully involved. Some of these are the Epilepsy Foundation, the Metabolic Support, specifically in the UK, and the United Mitochondrial Disease Foundation. Uh, that was my part now. I'll be giving it over to Nick to continue. Thank you.